Hi, my name is Yim Register, and this is Amy J. Coe, and we're from the University of Washington Information School. I'm going to walk you through our work that we did in the learning machine learning space. Yeah, that's a mouthful. It just kind of stuck, and now it's forever learning machine learning in our minds. So our paper covers how learning machine learning with personal data helps the stakeholders ground advocacy arguments in model mechanics. Whew, academic titles are brutal, I know. Feel free to think of it as learn ML on your own data, and it helps you stand up for yourself. So let's start at the beginning. Machine learning is now part of so many of our daily activities. There's some of the more obvious ones, like facial recognition filters, speech recognition when we're screaming at Alexa, or targeted ads. Then there's more subtle ones, like our Facebook newsfeeds getting automatically organized, Google search results getting ranked, and the machine learning behind content recommender systems. And then there are the many cases of machine learning models being used behind the scenes to approve people for loans, assess how likely they are to commit a crime, or targeted political content suggestions. Basically, models with the potential for harm. In order for everyone to have a voice in an ML-driven society, us educators have to be able to teach ML and enough literacy to help people affected by the models to understand what is happening. Let's check in with various strategies and research for teaching machine learning and data science in general. Some of you might be familiar with how machine learning is typically taught in the computer science department. Let me just jot down this super simple and obvious equation. Just kidding. How about introductory machine learning and statistics and data courses? Step right up for a fun and exciting exploration of iris plants. So many concepts are taught on these boring, unrelatable data sets that the learner can't even connect to. Besides, Ronald Fisher was a eugenicist anyways. We have a whole wide world of data, so maybe it's better to use relevant and interesting data sets for students to learn on. Even better, include them in the process of curating and exploring that data. You could use Corgi's data sets, take a look at Abigail Zimmerman-Neffield's work with athletics and machine learning models, or listen to the literature and try out customized datasets to the learner's domain. We know from the learning sciences that experiential learning can be beneficial, looking at philosophers like Dewey or Poppert. This work was especially inspired by something called funds of knowledge, work that shows using the cultural backgrounds and experiences of the non-white kiddos in the classroom really helps them feel represented and draws them into the learning because they can work off of domains that are intimately relevant to them. Okay, so all of this implies that the real magic is that the data was inside us all along. I know, very warm and fuzzy, but I'm kind of not kidding. We carry so many experiences, domain expertise, cultural values, insights, and ideas inside of us, and only a fraction of those will ever be represented in the machine learning classroom. So what would happen if we included personal experience when teaching machine learning? First of all, would that even work? What would it look like? But more importantly, would it help learners to understand enough of the machine learning to be able to speak up for themselves when models in the world go wrong? There are lots of sources of personal data, and in the pilot, we even used learners' own Instagram posts to build a regression model of likes and comments. For this study, we kept it focused on the academic context by asking students to rate their classes on how interesting they thought they were, and then reporting the grade that they got. We had surveyed some novices about what machine learning concept they'd like to learn about, and it was basic foundations. So I built a tutorial called Learn My Data that introduced linear regression and gradient descent, the machine learning algorithm that systematically hones in on the right parameters for the linear equation that best fits the data. We want to know the effects of using personal data on learners' ability to learn the machine learning mechanisms and to advocate for themselves. So we set up a study. First, there was the facts condition that mimicked a brochure or presentation where a bunch of bullet point statements are made about linear regression. This was the bare minimum instruction, and no, it did not actually take the form of a brochure that says, ML and you, your brain on linear regression. Then there was the impersonal condition, where learners used the Learn My Data tutorial, except it wasn't their own data, it was a hypothetical student's data that they learned on. And of course, I'm representing a student here by putting them in a graduation cap because that's obviously what we wear to school every day. Then there's the personal condition, where learners input their own data. For 5 classes, rate how interested you were in that class from 1 to 7, and then report the grade you got. Then it gets plotted on a scatter plot. For most students, their grades increase with their interest. Not me though, actually. I do worse in classes I like. Don't ask. We had 51 participants, pre-screened to be total data science novices, who got randomly assigned to a condition, learned about linear regression, and then filled out a worksheet. In the worksheet, they got to see some linear model scenarios that they might encounter in the real world. They got the chance to critique those models and write self-advocacy letters. More on that later. So they learned on the example of interest and grades. So what if there were some consequences of a model like that? Imagine an instructor wanted to help students who were struggling in the class and had students rate their interest at the beginning of the class. From last year's data, the instructor can predict how well each student might do. If the linear model predicts that the student will get less than a 75 in the class, the instructor reaches out and intervenes. We don't do this in our classrooms, I hope, but it's reasonable enough. The learner in the study was asked to write a letter to the instructor in the situation where the model has made a mistake. Next, we tested them on a whole new scenario to test generalization. Financial aid offices use models to determine how much aid families should get. The scenario imagined a model where the number of siblings the student had increased the amount of aid that the student received. They used data from last year from families who did not appeal the aid package. The learner in the study was then asked to write a letter to the financial aid office in the situation where the model has made a mistake. We can then analyze those self-advocacy letters to see how much they understood about the machine learning mechanisms and how well they argued their critiques of the models. But hold on, what is self-advocacy anyways? This work is inspired from disability studies, Goodly et al. Specifically, where people like me need to advocate for our needs within complex systems that may not understand our disabilities. Self-advocacy involves knowing your rights, negotiating where you can, collaborative problem solving, and understanding the inner workings of a harmful system. So these complete novices wrote self-advocacy letters for these scenarios, and we used thematic analysis and inductive coding to surface the themes that emerged. Learners mentioned lots of concepts like causality assumptions, construct validity, like what we were measuring, was that even valid? Confounds in the setup of the model, additional features you could use, whether or not the model accounted for outliers, and then model performance, how well the model even fit the data it had. All of those are indicators that the learner was paying attention to the mechanisms of machine learning, and we can actually count up how many each learner used in their self-advocacy arguments. On average, learners in the personal condition used more of the mechanisms of machine learning in their letters. This would be pretty good for self-advocacy arguments, which need good articulation of the problem and understanding of the inner workings of the harmful system. And this, of course, is the big result, which you are totally going to read about in the paper, right? Okay, but even if you just skim it, you'll get to check out some of the letters that learners wrote, and you'll see that the biggest driver of the difference we see comes from learners talking about model performance, or how well the model actually fit the data it had. The participants in other conditions hardly mentioned how well the models fit the data, whereas the personal conditioners were more critical. We theorized that the immersion in the personal data made them pay attention more to the modeling and also critique the problems in a more sophisticated way. Let's take a look at one of the letters from the personal condition. This model is limited in its ability to predict student performance in this class. Student interest is only one of many factors that influence class performance. Since the model does not take any of these other factors into account, such as time spent studying, previous experience with course material, or access to learning resources, it is unreasonable to use it to predict student outcomes. The university should conduct further research in order to make a more accurate model that more closely predicts student grades. Although interest and grade may be correlated, the instructor is not taking into account how good of a fit the model has to the data. Given that only one predictor is being taken into account, my guess is that the fit isn't very good. Therefore, the instructor should not be making decisions that directly affect student outcomes on an extremely flawed model. And as you can see, we had to learn to read a lot of messy handwriting. You'll see more letters like this in the paper, which you're totally going to read, including the high scoring and low scoring letters from each condition and more. So what are some takeaways? Give students and stakeholders of models a place to self-advocate. That could be letters, Google Forms, group discussions, post-its on a wall, debates. And involve the learner and their data. Allow them to explore real dirty data that makes sense to them. That could mean letting students do a project on their own Fitbit data, surveying the class on various topics and exploring correlations together. Measuring actual iris flowers by hand, who knows? I'm sure students will amaze and surprise you with their ideas. And for now, I have some discussion questions for us. What are some ways that you can integrate self-advocacy into your work? Next, let's do a personal data brainstorm. And keep in mind that some data isn't neutral. If we were to collect gender statistics right now, all of us non-binary people could either be outed or targeted. But for me, the point is still to prepare people to advocate in the real world, where that could be a real problem. So what are some good ideas around integrating personal data? And what do we do about the many algorithms we don't know the inner workings of? How can people advocate for themselves against those? Thank you very much. It's been a pleasure to share this work with you. And as it turns out, the warm and fuzzies might have been right. The real data was inside us all along.